simplify a fraction containing complex numbers, you need to multiply the numerator. All right, and denominator. So which one's the numerator?
The top.
That's correct. And therefore the denominator would be the bottom of the fraction. By the conjugate, big math word, which is very similar to something you do in foreign language, conjugation. But here, conjugate is really easy, and I'm going to show you how to find a conjugate in just a second. Okay, and this is called, ooh, that's really loud. Yes. Hold on, where's down? Is that better? Is that better? That's better. Okay, this is called rationalizing. The denominator. So when we have a complex number, a plus bi, its conjugate is very simple. All we do is change the sign of the imaginary part, and the imaginary part only. So you change the sign of the imaginary part. That's it. Okay, so here we have 2 plus 3i. So the conjugate of this complex number is just 2 minus 3i. We change the sign of just the imaginary part.
When would we know how to do it if it was like a mixed review worksheet? You know what I mean?
When would you know to do this?
Yeah.
I would have to say
Okay.
find the conjugate or give the conjugate. The directions would have to be very specific. Yes, ma'am.
What if it's a power?
A power you'd simplify first before you would ever.
Like how we did yesterday?
Okay, so here we have negative 5 plus 4i. Well, the negative 5 is real, so its sign does not change. But the 4i part is the imaginary part, so we change it to the opposite. So that's the conjugate. Okay, here we have negative 2 minus 5i. So the real part doesn't change, it stays negative 2. But we change the sign of the imaginary. So plus 5i. Okay, this complex number has 0 for the real part. So we don't even see it. So when we go to change the sign of the imaginary, it just becomes negative 2i. Okay, and you try number 5. Okay, so did you get 7 minus I?
Yes.
Okay, so now this conjugate is what we need to do division. So this looks, number 6, looks like we have a complex number divided by a complex number. Kind of looks like a fraction, doesn't it? So it's division written as a fraction. So our direction says we're going to multiply both the numerator and denominator. So we're going to multiply both of them by something. And we're going to multiply it by the conjugate of the denominator. So if my denominator is 5 minus 4i, what would the conjugate be? 5 plus 4i. 5 plus 4i. Now, let's talk about what we're doing and does it change the value. So this is division of 2 complex numbers. And I've rewritten it as multiplication. But whenever I take a number and divide it by itself, doesn't it have a value of 1? So I'm not changing the value of this at all. I'm just changing the form, how it looks. So now we basically have 2 multiplication problems. We have the top, which is 7 plus 3i times 5 plus 4i. And then we have the denominator, and I'm leaving some space here because I'm going to put the answer here and here. So we have 5 minus 4i over 5 plus 4i. I'm going to start with the denominator because whenever we multiply something by its conjugate, really cool stuff happens. So let's start down here. If I do 5 times 5, that is 25. And then 5 times 4i, that's positive 20i. So this is just like our multiplication yesterday. We're going to distribute the first term through, and then we're going to distribute the second part of the complex number, the imaginary part, through. So negative 4i times 5 is negative 20i. And then negative 4i times positive 4i is negative 16i squared. Okay, who remembers from yesterday what happens with the I squared? Okay, it's going to cancel out and do what with the sign? Change it. Now this is the cool part that happens every single time you multiply a complex number times its conjugate. Every single time the imaginary part cancels. Every time. These two are going to cancel. That is why we actually choose to multiply by the conjugate. Because when we multiply a complex number times a conjugate, the imaginary parts are eliminated. So this positive 20i cancels with this negative 20i. It's going to happen every time. That middle is going to cancel. This I squared turns that into just a real number instead of an imaginary number. So let's look at that denominator. What is left with the denominator? 41. 25 plus 16 is 41. Okay, so the numerator, we have to do the same thing, but cool stuff's not going to happen with the numerator. It's not going to cancel. We just do some multiplication. So today really has review in it. It has multiplication, it has powers, it has adding like terms. So we didn't have to put review on here. It is review. So 7 times 5 is 35. 7 times 4i is 28i. 3i times 5 is 15i. And then 3i times 4i is positive 12i squared. Positive 12i squared. But what happens with the i squared in the 12? Cancels out and changes that 12 to a negative. So now we have to do that adding the real parts together. 35 plus a negative 12 is like 35 minus 12, 23. 28 plus 15 is 43i. So this is the answer.
So what was the point of doing the bottom then?
Okay, the point of doing the bottom is when you have a fraction, we can never leave a radical in the denominator. Now, I doesn't look like a radical, but what does I represent? The square root of -1. It's the imaginary unit. So, just like we can't leave a square root in the denominator, you cannot leave I in the denominator, which is why we had to get rid of it. Oh, that's not what I meant to do. Come back. Okay, now, could show you a bunch of work on number 7. But do y'all see a GCF right here?
Okay, yeah.
Okay, so we're always looking for a GCF. I don't care what the problem is. What's the GCF here?
2.
2. What happens when I factor out that 2? It does. That's a little quicker, isn't it?
Yes.
Yeah. So when they cancel out, what's understood to be left in the numerator? 1. So this simplifies to 1/2. Oh yeah, that was a lot easier. That was almost misleading. It was so easy. Okay, now this one, there's no happy GCFs that make our life easy. So what we have to do every time is multiply the numerator and denominator by that conjugate. What is the conjugate of 3 minus I?
3 plus I.
3 plus I. Okay. When I distribute in the denominator, I get 3 times 3 is 9. 3 times I is 3I. Negative I times 3 is negative 3I. And negative I times I is negative I squared. Okay, did you see that these 2 in the middle cancel? They're going to cancel every time we multiply something by its conjugate. Every time. So guys, if you get to where you've practiced it enough and you know they're going to cancel, just do this one and this one. Now, normally we just slash it out and change the sign. But there's not a number right there. So what's that number understood to be? 1. So when we slash it out and change the sign, we have to understand that that's a plus 1. So our denominator, we're left with 9 plus 1, which is 10. And then our numerator takes a little more work. Okay, so we can distribute. So that gives us negative 2 times 3, which is negative 6. And negative 2 times I is negative 2I. And then distribute. Negative 5I times 3 is negative 15I. And negative 5I times positive I is negative 5I squared. Okay, so we slash it out and change. And then we add the real parts together. And we add the imaginary parts together. So we have negative 6 plus 5 is negative 1. Oops, I meant to switch back to blue. Negative 1. And then we have negative 2 and negative 15 is negative 17I. And this is our answer. Now, I will tell you that some people are nitpicky about how we write this answer. Back when I started teaching math before you were born, everybody insisted that all complex numbers be separated into the real part and the imaginary part, a plus bi form. Which means for this answer, I would need to split it into negative 1 over 10 and negative 17I over 10. So if you were to ever take like a multiple choice test, this answer might be written like this. So they might split it up into the real part by itself and the imaginary part by itself. Now, in the past 20 years, the pendulum has kind of been swinging the other way, and generally, it's okay to leave it like this. But if you were on the SAT or the ACT, they very well might write the answer like this. So I want you to know they're the same. Okay, I want you to try number 9. And I'm going to put some check steps along the way for you. If you're not sure what to do to start with, let me know. I'm going to pause the video while I answer questions. Again. Okay, so when we do this multiplication, we're going to multiply through on that numerator. Okay, so we're going to do this times this, which is 5. And then this times this, which is negative 25. And then the second term, we'll do this times this, which is negative 2i. And this times this, which is positive 10i squared. Now, we do like mnemonic devices in math, little things that help us remember what to do. And whenever you're multiplying a complex number times its conjugate, really any two binomials, when you multiply, you can kind of think of it by this word, FOIL, which means I multiply the first one here times the first one here. That means first ones. So the first 5 with the first 1. And then O stands for the outside ones. So I do the outside one here with the outside one there, the ones on the outsides. And then I, what do you think I stands for? Inside ones. So we do the inside one here with the inside one there. And then L stands for the last one. I do the last one of this complex number with the last one of that one. Now, you don't have to do that. When you distribute, it does this. But if you like to do the same thing in the same order every time, maybe FOIL would help you. The first ones, the outside ones, the inside ones, and the last ones. So that's what happens when we do that. So this I squared, it's like multiplying by negative 1, so it's going to change that to a negative 10. So the numerator is going to simplify to 5 minus 10, negative 5, and negative 25i minus 2i is negative 27i. Okay, I'm going to keep this FOIL in mind. The first one with the first one. 1 times 1 is 1. Outside. The outside one with the outside one. Negative 5i. Insides. The inside one with the inside one. Positive 5i. The last one and the last one. Negative 25i squared. Now once again, if you have decided when you're multiplying conjugates that you don't want to write those two because you know they cancel every time, I'm okay with that. Your math teacher is okay with that. So this I squared is going to turn that negative 25 into a positive 25 because it's multiplying by negative 1. So 1 plus 25 is 26. How'd you do?
Good.
All right. Okay, now this one, we talked about how if it has a GCF, You might want to factor it out, but if we factor out the GCF here, does it help anything cancel? No, it didn't do us any good. So we're just going to leave it in there because nothing cancels, and we're going to multiply through by -3 plus 6i. -3 plus 6i. So if, okay, we got 2 questions. Christopher, you first.
If there is a GCF, if there isn't a GCF, would you get the same answer?
If you didn't pull the GCF out, we're going to get the same answer because I'm going to show you both ways. Okay, so let's investigate. If it doesn't cancel, does it help us to pull it out? Let's investigate. Okay, so this would be one method where we did it. And so we would multiply through the numerator and we would get -3 plus 6i minus 3i plus 6i squared, which gives us -9 plus 3i. And then when we do the denominator, we would get 9 plus 18 minus 18i, so those would cancel, and then minus 36i squared, which is going to make plus 36, which is 45. Do you see that 3 divides into everything? So if we don't take it out here, it's going to come out right here. So now we would have to take the 3 out. Well, and that would leave us -3 plus I, and 45 is 3 times 15, and what happens to the 3's? They would cancel. So, if you did it to start with, it gives you smaller numbers, doesn't it? So let's see what happens here and see if we get the same thing. 1 minus 2i and 1 minus 2i. That will eliminate the imaginary. So my denominator has that -3, but then it has 1 plus 2i minus 2i cancels, so I'm not even going to write it down, and then minus 4i squared. Which ends up making a plus 4, doesn't it? And then my numerator is 1 times 1, which is 1. And then outside, 1 times -2 is -2. And then inside is positive I. And then last is -2i squared. So this is going to make a plus. That's a 4. No, it isn't. No, it's a 2. I'm sorry. I was right. It was a 2. Shame on me. I got confused. I was looking at the denominator for a second. Okay, so this gives us 3 minus I. Now, this gives me 3 minus I over -3 times 5, which is -15. Are these two really the same? Yeah, because what could this negative in the denominator do to those signs? Switch them to the opposite. A negative in the denominator would just switch the numerator to the opposite. And now, do they look identical? Yes. Okay. That was a tricky one. I think we may let that be our last one for today. I know there's one more on the page, but we'll let that one be our last one for today. And let me come by to make sure you took notes so I can give you your credit.